All right, so we have some troubleshooting to do. So thought I'd just throw you guys straight on the time lapse and I'd go to work and explain over the course of the time lapse, but we got problems. Got to turn you around and show you what's going on here. So I did the inspection first of the tail, as you saw, and looking down in here, we've clearly got some nylon stuff going on. Nylon looks pretty good, but we do have, it's hard to see. There are nylon clevises in there. Those will have to be replaced. Yeah, so moving up here to the fuselage, I just gutted all the wires for the lighting system. Just didn't make sense to have to work around them. Super frustrating part is that all of the electronics in this the wires were epoxied in. So like this servo was put in, and then like little daub of epoxy right there. And like right here, this extension right through here. Like, why? Why would you do that? Yeah, so I've got to take off the top canopy again and remove all of that stuff. I want to do like hooking this up and getting things to work, like this Y extension. Yeah, I'm not using this side because why you would use a Y extension on that, I don't understand like how this person was thinking, because you definitely need a computer radio because there's not a mechanical V-tail mixer in the rear. So, yeah, why a Y on these servos? Don't understand. Anyway, so like this, I had a servo extension going to the receiver. So this is going to get swapped out. I've got a nice tandem receiver down there for the radio, so we get 2.4 and 900. But here's the problem. Remove the servo. Yeah, I got to dig and get that out, which is kind of annoying. I've got a nylon clevis down here. I want to replace both ends, so I may as well go ahead and replace the push rod, right? That way it can make it simpler to adjust mechanically and things like that. Like use proper adjustment, like you know, an easy link. Good quality stuff, right? What happened here? What happened here? I can't remove this servo because, yeah, the screws are buried down in, like, seriously? You would never want to service that? So in addition to that, I don't know what happened here in terms of the length. Clearly they're the same length, but like, why wouldn't you turn the servo around like this one was? This one was put in here like that. Again, I don't understand. I did verify in the plans that these are the correct ply plates. So originally intended to be this way, but this isn't a great design. So this is where things get complicated. What I want to do is switch this up so that I want to build essentially a plate or a couple of rails where these servos, rather than having them sit like this, I want them to sit on the side, okay? By having them sit on the side, you can actually get to the screws and replace them and not interfere with the length of the servo and the wing saddle here, okay, right? Because that's really what we're talking about in terms of clearance. So I'm sure that's what ran into here. Like they thought, oh, well, this has to be on the opposite side of the servo because I need it to be opposite of this, thinking this was only elevator. No, you got to do rudder. You got to have rudder mixed in here. So independent servos, right? Independent servos. So this needs to be essentially cut out, ripped out, broken out, and then I need to create rails. I'll just use some scrap basswood from my supply, and I'll rotate these servo mounts to essentially look like that, and then flip it that way for that, so that we get this right. And then I've got these push rods. I'll just redo the push rods and use some threaded couplers. I'll use threaded couplers to screw in a metal clevis on this end, and then I'll use easy links on this end. It'll be perfect. Everything will be fine. I would use soldered clevises on the metal rods, just because it's easy. They don't need to be adjustable if I'm going to use easy links down here, but I don't have any of those on hand. Most of the time I use the screw-on type. So since I don't have any push rods that are long enough, I'm going to make my own using these threaded couplers. Shout out Dubro, catalog number 212. Awesome sauceum. That is a whole lot of talk to explain what I discovered over the course of 15 minutes, just trying to troubleshoot. And that's really what happens with these restoration. Like you go in, you think you're going to do something simple, then you find out there's more work. All right. So that's part of the experience I want to share with you guys. I'm going to go ahead and do all of this stuff off camera because it's not terribly difficult. The only tip that I'm going to give you guys is that doing the threaded couplers on the push rods, use a torch. Make sure that you've got everything super well heated. Use flux and then use mechanical solder. Do not use electrical solder. Don't do it. And then clean up with ketchup, like I always recommend. Ketchup and maybe a wire brush. Ketchup usually cleans it up right away. The acidity, it's the acidity in the ketchup that helps clean up the solder joint. And then I can slip it in from the rear, get everything cleviced in place down here. And then as I slide in new servos, I should be able to get things to seat properly, okay? So it's gonna take some time to get all of this together, but I wanted to share the journey with you. All right, so it's a new day. I'm trying to get some stuff wrapped up, and I want to show you guys something that I learned not from instructions on a piece of paper, but just through experience, and that is grommets, servo grommets specifically. So servo grommets are one of these things that a lot of people go back and forth on, and I find that the argument is really quite simple. Grommet direction is the argument. And the reason that we have the grommet is because we have these rubber isolators that I just installed. Now you can take the grommet and you can install it from the top. That's fine. But what's going to happen is when you mount your servo, this brass is really sharp and it's going to dig into the wood. And as you compress it with the screw, it's also going to compress your grommet. Your rubber isolator. So really the proper way, unless you're going to mount from the bottom, like a beam bottom like that, really you should be pushing your grommets in from the bottom so that the flange is facing down. The reason for this is that when you go ahead and install your screw, the screw will press down on the sharp part of the brass, like the screw head, because remember, these are usually pan head screws. So the screw will go down on the sharp part and compress against the flat part, and that will prevent it from digging into the wood and over compressing the rubber isolator. And that way you've got a better use of your rubber isolator for vibration. Now, this is not necessarily as much of a concern for electrics. I have done hard mount servos on my electric before with no issues. But there is something to be said about glow and gas planes. You really should be isolating vibrations from your servos because of all the moving parts and sensitive electronics that sense the position of the servo. So just a quick tip there before I install this into the model, and I'll come back and show you all the work that I've done. Well, they say that the best laid plans are paved with good intentions. I had good intentions here, but this was a complicated one. It seems like a hodgepodge, but there are reasons. So let me show you what I'm talking about. Within the fuselage, we have construction that is not symmetrical. Okay, so it's not symmetrical, meaning that these push rods do not come out the same distance from the edge of the model. So in addition to that, they don't come out the same vertically on each side. So I've had to use kind of a hodgepodge of methodology here. So there is a screw, as I mentioned before, the threaded ends on each end, so I can adjust this way a little bit on on those, but we do it through on this one by rotating up here. Okay, so the only way that I could do this, because I couldn't get an easy connector, these are easy connector, these things, that's called an easy connector, right? So I couldn't get one on top because it was going to dig into the wing. And so I had to go with a Z-bend. And even the Z-bend is sort of like pushing almost to the top of the wing. So I may end up having to file that off a little bit, but I think I have enough throw in the stabilizer, so should be good. Now on this side, because of how far over it was, I could use an easy connector, but I had to push it down. And because, again, I have that ability to rotate, in order to do the adjustment, you have to take it off the servo and then loosen. And then, so, you know, I could have done an easy bend there, but I did this one first, and that's how I figured to do it. And then when I came over here, I'm just like, oh, well, I have to use a Z-bend. Not my favorite, but it works, and it works well. There's very little slop, and I'm happy with the safety and controllability from this point on. Now, moving forward, I have all of this stuff because, I mean, servo, oh, that was a dummy servo, throw that away. So these servos that are still stuck in here, I have to dig those out. In addition, I have this old receiver that I have to replace, and I'm going to go with the TD. This is a TD R10. Doesn't have a case on it, but that's okay. It'll still work. Coming to me secondhand, but I'm happy with it. It works. I've got firmware updated, and it should be great. So what I really have to do at this point is I have to take the canopy off and go inside, basically remove the tank again, and try to install the what's his name, the receiver, and get everything connected. And I'll do some servo leads from there. Should be pretty straightforward. I'm going to use some foam rubber for that. Again, vibration, right? You don't hard mount stuff. Okay, we learned that today. Also, other thing I need to do in the fuselage is the connections. Let me turn you around and show you what I mean. I should have specified the pneumatic connections. So these, I need to replace these, either the entire fitting or replace the O-rings. The reason is that there are some O-rings that are cracked. The one that goes in on this end, the O-ring is cracked. So I want to make sure that I have a good seal and that I don't lose air pressure during flight, obviously. In other models, I use something called lure connections. They're just barbed fittings that sort of half turn into each other. You can get them on Amazon. I prefer these because they're sort of what I'm familiar with being in the scientific field. They hold a lot of pressure and they work really well on my other models. And there's no O-ring. It's all friction fit and it's really tight. Yeah, I mean, they're designed to hold hydraulic pressure, and hydraulic pressure is going to exert more force than pneumatic pressure. So, given the same PSI, because mass, right? That's the way it works. Force equals mass times acceleration. So if your pressure is your acceleration force, and you've got little mass, not being a fluid, being a gas rather than a fluid, all right? So we can math together on the simplest of terms. So that is the things that I have yet to do on the fuselage. I do want to replace the steering servo, but it's all pretty much the same rinse repeat kind of stuff. So there's more to come on that. There has been a little bit of development on some bobs and bits for this model. But I'll get into that when the time comes. In the meantime, I'm waiting for my prop to arrive, a different prop for this. And yeah, we're going to keep going, breaking in the engine and knock out this thing one little bit at a time. Thank you so much for tuning in. Go ahead on over to dubro.com, get your easy connectors, and make sure that you use that code Josh10 in checkout for your 10% off. I get nothing from it. It's not an affiliate link. So it's strictly for you guys to thank you for watching, tuning in, and the work that I do with Dubro, they appreciate. So it's a win-win for everybody. Until next time, I'm going to keep refurbishing my flying work of art.